All right, so I wanted to make this visual aid to show um, how the globe model works when it comes to the distances in the measurements of 15 degrees per hour from the shortest day of the year to the longest day of the year. And just FYI, if you go to my website, I have actually measured the sun's position in the sky many, many times throughout the year. So the the information's out there if you want to check that out. But here's what observed reality matches. And in this case, we're measuring the sun's uh, position in the sky. So this is December 21st. This is the shortest day of the year. And we're going to take our first measurement in this position, and we're going to mark that as solar noon time. And then what we're going to do, we're just going to move the globe at 15 degrees. And then this is going to be our second measurement to the sun. Now, these bars that I'm using are equally, the lengths are equal on both of these observations that we're doing. So when you look at this is a 15 degree angle. And so the first position was measured over in this position, right? And so as we move 15 degrees, now we're observing the sun measured in this position. This distance is important. This distance doesn't change in the sky. So from point A measurement to point B measurement in the hour doesn't change. So I'm going to show you this visually. Okay, so there is the December 21st, 15 degree measurement. Okay, so the position of the Earth here is going to be at the June 21st position, the longest day of the year in the Northern Hemisphere. So we're going to take, again, our solar noon measurement here, where it's pointing straight to the sun, okay? And then what we're going to do is just rotate it at 15 degrees. And then we're going to take our second measurement of the sun's position here, okay? So again, was our first one. That was taken solar noon. Boom, right? 15 degrees later, 1 hour later, 181 to 196, right? There, right? So this is our second measurement here to the sun. Boom, okay? So this distance is the exact same distance as it was December 21st. This is what we observe in reality. We observe a 15 degree, same distance apart per hour sun position, both on June 21st and over here on December 21st. This is how the globe model works. So if somebody says something different than that, that's not true. We will always measure a 15 degree position, for the most part, all over the Earth, on the longest day of the year and the shortest day of the year. So on the flat Earth model, from the same position of Earth, right? If I'm on June 21st, the sun's position is here. 1 hour later, because this is 15 degree angle, is here. So from here to here, 11:30 to 12:30, for example. Take a picture 11:30, take a picture at 12:30. This is the distance between 11:30 and 12:30, June 21st. From this position. Now, from this same position, December 21st, when I take a picture of the sun in the sky, the sun is going to be here at 11:30, and then the sun is going to be here at 12:30, traversing a further distance across the sky. So when you look at it from this position, June 21st, the sun is going to be this far apart in 1 hour. December 21st, the sun's going to be this far apart in 1 hour. And that's not what we measure. it's always the same distance apart per hour, the shortest day of the year and the longest day of the year. That's what we're talking about here. Distance over time. This is June 21st. This distance is December 21st. And when I measure that distance between the time, 1 hour to 1 hour, that's not what I measure. I measure what the globe predicts. You guys take care. Have a great day.